This year is a special one for me. It marks 2 decades in the tech industry. I was lucky enough to take part of multiple projects, from mobile and embedded devices up to cloud systems. I work from tiny projects that has to be heavily optimized to the byte, up to millions of users to be onboarded at the same time inside a cloud platform. Overall, I always try to think holistically about a project, looking on different dimensions. But what I missed, what I really didn't intentionally optimize for, was only a dimension that unlocks all the others. And this dimension is modularity. What I mean by modularity? Modularity is the quality of consisting of separate parts that, when combined, form a complete whole. But also, a system lacks modularity the moment that we tweak one part, and one or more other will be affected by this change. And this is not a definition that is coming from tech. This is a definition that is coming from the Cambridge Dictionary. So something that is not even strictly related to tech. And now we see how important is the concept of modularity in software design. But why do we need modularity? When we think about designing a software with modularity in mind, in reality, we are expressing some characteristics that the business would like to have. They are looking for agility in order to drift from one direction to another one. Think about the pandemic. During pandemic, a lot of business required to change very drastically the way how they were operated, the direction of travel they were taking, into something that was sustainable for that specific moment. At the beginning of my career, very often, when after 6 months, 1 year that I was working into a project as engineer, I realized that we reached a point where we were dealing with spaghetti code. And it was very difficult to untangle the complexity that we created. We started to have tech debt. And therefore, at some point, we reached a moment in time where adding a new feature became a monumental chunk of work. What you want as a developer, you want to rebuild everything from scratch and be more disciplined and try to apply what you missed during the configuration. But the reality, with time, I understood that starting from scratch is very often not an option, and I would say almost always is not an option. And therefore, we need to really understand where the friction is, because this signal that is very difficult to introduce a new feature is nothing more than a friction that the system is telling us to address in somehow. Sometimes could be at the code level, sometimes could be at the organizational level. Sometimes could be that the business requirements are too complicated to build on top of a system that weren't meant for those. Too often, we immediately point the fingers towards architecture. But in reality, a system is composed by multiple dimensions. We need to think about architecture, we need to think about organization structure, and we need to think about culture. That we like it or not, these 3 dimensions will be coupled, and therefore every time that we touch one, the other 2 will be affected. What it means is that, for instance, if we decide to go through a monorepo or a polyrepo approach, we're not only taking a design decision, we are shaping the way how our teams are communicating together. So don't be fooled that everything is just a technical decision. There has a direct impact on other dimensions inside the system and inside a company. We also need to bear in mind that in modern architecture, there is no solution that fits them all. We need to find the right tool for the job. And very often what was working for one project is not going to work for another one maybe. Because in modern architecture, we understand that there isn't just the best practice or the best architecture. We need to deal with trade-offs. We need to deal with understanding if a specific best practice can be applied inside our system. As Neil Ford and Mark Richards are used to say, if you think you have found something that isn't a trade-off, it just means you didn't identify the trade-off yet. How modularity can manifest inside the system? We can apply modularity at the infrastructure level, or we can implement modularity at the code level. By the way, they are not mutually exclusive. You can use both and apply the right level of modularity when we are writing our applications. Think about modularity at the code level. We're talking about maybe design patterns. We talk about sharing libraries. We're talking about packages. We're talking about functions. We're talking about methods and so on and so forth. At the end, what we want to reach when we apply modularity at the code level is a cohesive code base, because when other people are contributing to it, it should seem that it's written by a single person, and everyone can understand the patterns that were applied, how it was structured a package, or how it was structured an interface, and so on and so forth. And usually in this case, what we have is obviously less operational option. You define where your three-tier architecture or monolith will be hosted, and then you set up your CI/CD, job done. At the same time, there will be more overhead for the teams, where usually they tend to work in every part of the system. They can, let's say, start from one domain, move into another domain of the system, and they will be able to put their hands on it. And that means there will be a higher cognitive load that they need to bear in mind, because they need to squeeze in not only the technical part, but also all the different business requirements and the edge cases that are associated to it. These will require more discipline, and therefore we need to take the time in order to understand how to apply a specific feature inside our code base, because otherwise we create so much tech debt. That also means, on the organizational level, that when you onboard a new joiner or a new member inside a team, you might risk that it will take longer to start contributing inside the code base, because for better or worse, they need to understand holistically not only the part that they need to fix, but maybe also other parts that are associated to that specific application. Obviously, not all workloads are the same and should be treated equally. Therefore, also, we can apply modularity in a different dimension, at the infrastructure level. So there, usually you think with decentralization in mind. And bear in mind, it's not only a technical decentralization, it's not only for services that are breaking apart from a monolith into microservices, for instance. It's also organizational. So now we want to have teams that have skin on the game and they start to take decisions inside a system. You start to have the possibility to choose the right tool for the job. So maybe instead of dealing always with a Postgres database, you start to decide and choose maybe a graph database or a vector database or a NoSQL database for a specific bounded context inside the system. You finally have teams that became domain experts, and therefore they can help you not only to write code, but also contributing to the product. And they start to add value end to end, and they start to feel the ownership of what they are building. And finally, you reduce the cognitive load, because now a team is responsible for a portion of the system. They don't necessarily need to immediately, day one, understanding the entirety of the system. They might eventually, depends from the role and depends from the seniority, but in reality, if you onboard a new person, they will be able to contribute faster. But at the same time, the trade-off of using this approach is that a team now has a smaller scope of work, but has to take care about more stuff. That could be maybe the CI/CD, or maybe they need to understand a bit of infrastructure in order to, let's say, operationalize their system. They start to have a variety of work that they need to think about. Maybe the security aspect of their service, or maybe adding some special logs or an integration with another microservice that is required and has to be standardized across the entire system. And definitely they need to be more intentional on how to apply the governance. What happens when we want to update a shared library? What would happen if they need to change across the entire system the security mechanism for communicating between microservices? So these are not afterthoughts anymore. You need to think thoroughly about that and understand how to apply intentional governance in order to simplify these aspects of the work. But let's try to make an example between these two modularity approach that can happen at the code or infrastructure level. Let's talk about reusability. Think about a shared library. In a monolithic space, what I need is a shared library that abstracts a certain complexity and maybe I can use across multiple classes in my system. Now that shared library, when needs to be updated, I can go easily inside my code and quickly change wherever is needed. On the other hand, when we apply modularity into infrastructure, we are changing slightly the way how we should work. But there is some great perks in this approach. For instance, imagine that you have this new library, maybe an observability library that has to be spread across all your microservices. You can potentially create an automation that behind the scene every night is running in order to check if the microservices are compliant with that specific version of the library or the latest version of the library. But also, you can decide that it's not that important that a specific library is updated in one go. And maybe you can decide that you accept that certain teams will use an older version of the library, maybe because it's a minor version or a bug fix version or whatever it is. So as you can see, you have a different type of flexibility in this case that you can use across your system that before it wasn't possible because you replace everything in one go. Now, before you start big flame thinking that I'm in favor of microservices over monolithic architecture, but sorry, big spoiler, I'm fine with both. None of these solutions are wrong in my opinion. It really depends from what you need to express inside your system. Because the reality is that the context should drive this decision. I have heard so many times that we should use that architecture because this giant enterprise is using it. You might not be that giant enterprise, and the process and the engineering culture and the context where they operate is completely different from yours. So instead, it's by far more productive if we start to understand the learnings and start to understand how our system works, what is the context, how many teams we are dealing with, and then apply the right approach for our context. Another great thing that modularity enables you to think about is the granularity of your services. That's how micro is a microservice. This is the question I hear all the times. And unfortunately, there isn't a way that we can say, oh, 500 lines of code is a microservice. More than that, it is not. We need to be slightly more nuanced in the way how we answer. So a great answer that I have found in the philosophy of software design tells that there are two types of services. There is a shallow service and a deep service. A shallow service is usually a one that has an API and a very thin business logic that usually is just taking care about writing and retrieving information from a database. But the problem with that every time that we are changing our database schema or the way how our database is organized, we need to change also the API that is exposed to the different other services. On the other side, what we really need is having a deep service, having an API that is stable enough that obviously if require breaking change, we will introduce nicely. But at the same time, if we are going to change something that is specific to the data and is going to change in a way that shouldn't affect all the other system because it's well hidden behind this deep module, we will be able to without affecting the rest of the system. And there are multiple dimensions that affects the granularity that we want to have. Code volatility, how often a specific portion of the code is changing. Can I collocate two of them that require maybe a higher level of intensity at the beginning for writing the code, but then they don't change very often, and therefore I can group them in an area of the system without the need of breaking it further apart. Or instead, there is an area wherein it requires often changes and therefore we need to think differently on the way how we are writing the code and express more modularity over there. How extensible the code should be. What is the scalability and throughput of the API? Because maybe if I require to scale in a certain way, maybe I can isolate that code for that specific service while the rest of the application remain more stable and doesn't require to scale at a massive approach. Like, you need to think about the service scope, the security, and many other dimensions that helps you to understand the granularity and the modularity that you need to apply inside the system. But if you think about that, modularity enables you also to embrace different entities inside software architecture. Let me give you an example. Let's think about maintainability. If I write spaghetti code and everything is there, every time I want to touch one part, it will be extremely painful. It will require a lot of time, and it's not going to be a pleasant experience for anyone. But if I start to break apart my monolith in different areas that are well defined, they have different boundary contexts inside my monolith, and I started to tweak it without affecting the rest of the system, then it became very easy. Apply the modularity inside the system. Similarly, if I apply the same concept into a microservice and I have low coupling between microservices, then it became very easy for me changing one microservice, and without affecting the rest of the system, I will be able to deploy, and I can start to iterate into that. And now one of my favorite, portability. And when I think about that, my mind immediately goes straight into how I can take the same business logic and apply multiple types of infrastructure, maybe moving from a VM to a container, or from container to serverless, or vice versa if needed. And when I think about that, there are patterns that helps you to modularize their code and isolate very nicely your business logic away from the environment where it's running. So let me give you an example. So if you think about a Lambda function, you can write a code that is related on the business logic, isolating from the primary actors that are coming and invoking the Lambda function and the type of storage you decide to have. This is called hexagonal architecture. It's a pattern that there is out there for a while. And what helps you is to modularize and segregate the most important part of your application, the business logic. Thanks to that, you can take the different adapters that are communicating with the external world, either in forms of primary actors, so the trigger for a Lambda function, or to a database or a cache that you decide to have or whatever. And the business logic will remain completely unaware where those things are ending. And thanks to this approach that is also called port and adapter, we can take the business logic, move into a controller of maybe a container, or moving from a container into a Lambda function without too many burden, because the only thing that we are going to change is this tiny part that is the adapter, that is just shifting the way how the communication is happening with your business logic. Starting from the business requirements, understanding what you need to express inside your system, and secondly, matching the business requirement with the architectural characteristics that are defined inside your system. You have no idea how often I ask about what is the SLA of a specific service for receiving an answer that either I don't know or at the fastest possible. But the reality is designing something for the fastest possible outcome, but that will require a lot of effort. Is it really needed for your system? How fast is fast? Is it a second fast? Is it a millisecond fast or slow? So we need to understand what are those SLAs and use them in order to design our system properly. Because remember, it's developers' misunderstanding, not domain expertise, that gets released in production. This is by far one of my favorite quotes in software engineering, because that's exactly what happens when we are not thinking about the other two dimensions that I mentioned before. And therefore, for me, the best way to solve this problem is communicate and visualize. How to do that? But domain-driven design is helping a lot with mechanisms and practices that you can use in order to do both. I don't want to do a masterclass on domain-driven design, but I want to give you, for me, the main takeaway of domain-driven design. Effective communication is the central topic of domain-driven design. What we want to achieve is removing the barrier between product and business to techies in order to have a team that is holistic with the different disciplines and capable to express exactly what the business wants with the architectural characteristics that are needed and map that into infrastructure and code. And what we have seen with a very well-known book called Accelerate, where there is a study of hundreds of high-performant companies and trying to understand what are the traits that characterize those companies, we can see that a fast feedback loop is essential. And therefore, thinking about deployment frequency or lead time for change, time for restore a service, all this kind of dimension becomes a mandatory thought when we are designing our system. Because the reality is modularity creates tension inside the system. And it's not that it's going to fade away, you are just shifting from one part to another one. And the only way to solve this problem is balancing your decision, start with the trade-off analysis, understand what you're losing, what you're gaining, and find the least worst approach that will work inside your context. We need to remember that we do not operate in a scientific world. We are operating in an empirical one. So it's very important that we treat what we do in an empirical way, with trial and errors. If you embrace the PDCAI cycle inside your systems and inside your practices, then you start to understand that the things are changing. Because you start to plan what you need to release, you start to implement or do what you decided to implement, you start to check the result and act upon the results, and start to tweak the system in the way that you want. If you think about Scrum, this is exactly what it's doing. It's just providing you a cycle that is of 2 weeks, 1 week, depends how you want to do that, or any other agile practice, and trying to embrace that in a structured way. You can be more rogue and do your own way, it's fine. But as long as you start to have this continuous improvement mindset that is reassessing your decision every now and then. Because remember, friction inside the system is a gift. Friction is telling you that there is something that is not working inside your system. And you need to analyze multiple dimensions. It cannot be just the architecture the problem, and it cannot be only the code the problem. It might be also the organization structure. It could be some lack of investment on the automation culture. There are a lot of dimensions we need to take care of, and we really need to understand why a friction arises inside the system and where we can tweak our system to remove or alleviate the friction. So one thing that I want to say that is something that bothers me for a while is that very often developers or companies are blaming the architecture because it's not suitable for them. But in reality, the architecture is just expressing certain characteristics that were defined up front. If you didn't do your job on understanding your business requirements and what kind of architecture characteristics you are implementing inside the system, you cannot blame the architecture. Do you want to know what I understood after all these years in the trenches? The modularity can really help me to design a social technical system and enable me to become a better architect and a better developer. But in order to apply proper modularity, we need to gain experience. And for me, there is no such things like failure. There are only learnings. And that's a very important aspect, because when we fail, it means that we are learning something new. And when we learn something new, we can apply for the next iteration in order to avoid to make that mistake. So let me finish with one important message. Remember that you need to grow your software, not build them. Because growing starts from the idea that you need to nurturing your software, you need to evolve your software, you need to take care of that. Building is just an action that has an end. But in software, the only thing that we are sure 100% is that there is always the next change.